Assalamu alaikum. I am Gulam Kibriya, student of Tripoli Department, World University of Bangladesh. I am in 9th semester. My roll number 4354. Base nong 69A. My course name Power System Operation and Control. Today my presentation is case study of power system operation and control. This is my top page. This page is content, serial number, name of topics and page number. This is lesson 1, load forecasting, page number 1, classification of load forecasting, page number 2, forecasting procedure. Lesson 2, characteristics of power generation unit, page number 3, system variable, page number 3, optimum distance for modulation, input output characteristic curve of system unit, page number 4, incremental fuel cost cover, page number 5 to 6, incremental efficiency, page number 6 to 9. Lesson 3, topics, developing the mathematical for economical load dispatch, problem 3.1, page number 10 to 11, problem 3.2, page number 12 to 14, problem 3.3, page number 15 to 18. Lesson 4, topics, unit commitment, necessity of unit commitment, forecast effect unit commitment, and this page number. Lesson 5, economical load dispatch problem 5.1, page number 24, combination of the unit and their status for the dispatch of 600 megawatt load, table 5.1, page number 25, and figure 5.1, simple peak value load pattern. And lesson 6, this topic number and page number. Lesson 7, this is topic and page number, and lesson 8, topics and page number serially. Lesson 9, topics, page number. Lesson 10, this topic and page number, and lesson 11, this topics and page number. And lesson 1, first topics, load forecasting. The elimination of load in advance in commonly known as load forecasting. It is necessary of power system planning. Purpose of load forecasting: 1. For proper planning of power system, for proper planning of transmission and distribution, forecasting. For proper power system operation, for proper financing, for proper manpower development, for proper grid formula, and for proper electrical cell. This is details for load forecasting, and this is classification of forecasting. The load forecasting can be two classification. One, determined demand forecasting. Two, energy forecasting. Forecasting procedure: short term, medium term, and long term. Lesson 2: characteristics of power generation unit. This figure thermal generation system. First fuel input, then boiler, then steam, then turbine, then machine power input output to generator, and electrical power output. System variables. To analyze the power system network, there is a need knowing the system variable. They are: 1. Control variable PG and QG, disturbance variable PD and QD, and static variable V and S. Optimum dispatch formulation. Let the total load demand on the station PD and the total number of generating unit N. The optimization problem into allocate total load PD among the N unit in a optimal way to reduce the overall cost generation. Let PG1, PG2 and PG3 to PGN be the power generated by each individual unit supply and load demand of PD. For instance, if N equal 3, PD equal 500 megawatt, then PG1 plus PG2 plus PG3 equal PD. This figure is input output characteristic of a system unit. The vertical line is fuel input and horizontal line output in power output in megawatt, PG minimum and PG maximum. Cost curve. To convert the input output curve into cost curve, the fuel input per hour is multiplied with the cost of the fuel. Incremental fuel cost curve we know incremental fuel cost curve del input divided del output equal del F divided del P0. The IFC is no obtained ADIC equal slope of the fuel cost. This curve incremental fuel cost characteristics in terms of the slope of the input-output curve. Mathematically, the IFC curve expression can be obtained from the expression of the cover cost curve expression. C1 equal 1 divided 2 dot A1 PG square plus B1 PG1 plus D1 second degree polynomial. The IFC definition and definition DC1 divided dPG1 equal IC1 equal A1 PG1 plus B1 linear approximation for all I equal 1 2 3 dot n. Here DC1 dP divided dPg1 is the ratio of incremental fuel energy input in BTU to incremental energy output in kilowatt hertz, which is called incremental the thermal unit of most efficiency at maximum heat rate. This curve incremental efficiency. This first discussed is incremental efficiency, and this law of formula equation. Lesson 3 importance equation. The cost of ITS unit is given following the equation. CI equal 1 divided 2 dot AI PGI squared plus BI PGI plus DI. And problem number 3.1, the fuel cost of 2 units are given by C1 C2. If the total demand is generation is 200 megawatt, find the economical load spreading of the 2 unit. This problem solution. Given information C1 C2, the condition of economic load escalating when negotiating the transmission loss is dc1 divided dpg1 equal dc2 divided dpg2 equal lambda. Differentiating equation 1 with respect pg1, this equation dc1 dpg1 1.0 division is equal 0 and pg1 definition is 1.2 and 25 plus 0.4 pg1 Tika divided megawatt hertz. Differentiating equation 2 with respect Pg2, dc2 divided dpg2 equal 35 plus 0.4 pg1. For equation 3, (25) plus 0.4 pg1 equal 35 plus 0.4 pg2. (0.4 pg1 minus 0.4 pg2 equal 10 megawatt and pg1 plus pg2 equal 200 megawatt. Solving the equation 1 and 2, pg1 on 2.5 megawatt and pg2 at 7.5 megawatt. Problem 3, and this is problem 3 solution. Problem 3, and this solution. Lesson 4, unit commitment. The total load of the power system depends upon consumers. It is different peak value throughout the day. The number of running generating unit depends upon the value of total load of the particular time. Unit commitment UC is a computation process. Select a running generation unit in advance for the particular time a day. The topics necessity of unit commitment. Number 1, number 2, number 3, 4. This is commitments and unit discuss. Factor affecting unit commitment. This spinning reverse, start up cost, computational process of unit commitment. Lesson 5, example 5.1. This problem, let us consider a plant having unit, the cost characteristics and minimum and maximum limit power generation of each unit are following: is C1 0.002842 Pg1 squared plus 8.46 Pg1 plus 600 C2 C3. This equation to supply a total load of 600 megawatt must economically the combination of unit and their generating status as tabulated in table 1 number of combination. Important equation: the cost of unit given following equation: C1 Ci equal 1 divided to AI Pgi square plus Bi plus Pgi square plus Di. This equation is through the problem example 5.1. We solve the problem. This table is 5.1 combination of the units and their status to the dispatch of a 600 megawatt load. This figure is simple peak valley load pattern. This topic UC operation simple peak valley load pattern shutdown rule. Table 5.2 shutdown rule derivation. Load optimism generation unit 1 2 3. This figure and discussion on usage schedule using the shutdown rule. Lesson 6: priority list method. Let us consider a plant having their units, the heat rate characteristics and minimum and maximum limits of power generation of each unit are follows: H1 0.00142 Pg1 plus 7.2 Pg1 plus 510. H2 equal H3 equal with the fuel cost 1.1, fuel cost 2, fuel cost 3. Table 6 fuel load average production cost. This is unit and fuel load average production cost. 1 9.79 and 2 9.48 and 3 is 11.188. Table 2 triggering The table 1 based on average production cost. Unit 1. This is cost by megawatt hours, power, maximum power and minimum power. Table 6.3 combination of unit for the load from 1200 to 400 megawatt. This is combination power maximum combination, power minimum combination, and this power maximum combination. Table 6.4 shutdown rule for the load from 1200 to 500 megawatt. This is load optimum generation unit 1, unit 2 and unit 3. Lesson 7. The frequency control. This topic is frequency control and discussing the system. This topic necessity of maintaining frequency constant. Lesson 8. Governor characteristics. This figure is 8.1 characteristics of typical generation, and this figure is speed generation and PF controller, and discards this controller, and this topic QB controller, and it is discussion, and generator controller, PF and QB controller. This figure generator controller. This is turbine and this is generator. Right side ABR loop, left side ALFC loop. Lesson 9. Speed generating system. This figure is speed generating system. Example A 125 MVA turbo alternator operator on fuel load operates at 50 Hz. A load of 50 megawatt is suddenly reduced on the machine. The system value to the turbine commands of loss after 0.5 a due to the time long in the generator system. Assuming the inertia to the constant is equal 6 kV. Per kVA generation capacity. Frequency that occurs in time solution. Given information, capacity of machine equal 125 MVA, frequency 58 Z, load charge 50 megawatt. Generator response time 0.5 second. Generator inertia constant is 6 kV SK by VA. F nu equal what? We know generator inertia constant is equal stored energy divided capacity of machine. So energy stored at no load 6 into 125 into 1000 equal 750 mg. Exclusive energy input rotating part in 0.5 second equal 50 into 0.5 into 100 equal 25 mg. Example 9.2. And this solution in this phase. Lesson 2, lesson 10, example 10.1. Two generating station 1 and 2 have full load capacities of 200 and 100 megawatt respectively at frequency of 50 Hz. The two stations are interconnected by induction motor and synchronous generator set with fuel load capacity of 25 megawatt as shown in figure 10.1. Find the load taken by motor generator set. This is solution. And lesson 11, power system security. Operating planning on the line of operation, security analysis. So this is my case study presentation.